Welcome back. In the next part of this section, we're going to start looking at some operations that we can do with sets. So in addition to just defining a set, we can combine two or more sets together using one of these operations. One is called the union and the other one is called the intersection. So first off, the union. When we're talking about the union of two sets, the symbol that we use would be this symbol that looks sort of like a letter U. So I would write A union B. That's how I would read that out. That's the union of A and B. And what does it actually mean? Well, when we say the union of two sets, those are the things that are inside of A or inside of B or maybe inside of both of them. The key word here is or. So when we're thinking about a union, we're thinking about the word or. For an intersection, on the other hand, the symbol is reversed. Instead of being like the letter U, it's almost like an upside down letter U. We would read that as A intersection B, or the intersection of A and B. And those would be the things that are inside of A and also inside of B at the same time. So when we're thinking about an intersection, we're thinking about the word and. So if we're thinking about these operations, basically we have an operation for the idea of or, and we have an operation for the idea of and. One thing we have to be careful about, and I was really clear in my wording here, and I just want to be careful for the future. When I said inside of A or B, I said inside of A or B or both. And that's because in math we use the word or slightly differently than how we use it in everyday language. In everyday language, you often use the word or to mean either or. So you're at the coffee shop and they ask you, do you want coffee or tea? They're expecting you to answer one or the other. They don't want both as your answer. They're hoping for you to just say just coffee or just tea. In math, on the other hand, when we use the word or, we use it usually inclusively, unless we say otherwise, unless I use another word like either or only. If I use the word or, I'm using it inclusively. So when I say A or B, I mean A or B or maybe both. A couple of other things to also notice for the future. We might be interested in combining more than two sets. So maybe it's not just an A and a B, maybe there's an A and a B and a C. So just like with regular algebra or arithmetic, we're going to use brackets to give shape to things, to tell us what takes precedence over what. So just like in arithmetic where you need to deal with brackets first, same thing would be true here. So if I was interested in figuring out what is this expression A union B intersected with C, the brackets are telling me that I need to first know what A union B is, and then once I've done that, then I could figure out what it is when it intersects with C. All right, time for some examples. We've got ourselves four sets, A, B, C, D, and they've all got nice finite size, so they're all small enough that we can just list everything that's inside of them. So let's start off with the first one, A union B. So for A union B, remember I'm going to be listing anybody that's inside of A or inside of B or inside of both of them. I have to remember a couple of things. Number one, it doesn't matter what order I list my numbers. Number two, I need to make sure that I only write things down once. So I'm going to start off by first writing down that inside of A, you've got a 1 and a 2 and a 3 and a 4 and a 5. So all of that stuff will need to be inside of A union B because we're taking everybody inside of A or anybody who's inside of B or anybody that's in common for both. So I've taken everybody that's inside of A, and now I'm going to also add on to the mix everybody who's inside of B. Some of these I've already listed. 2 has already been listed, so I don't need to list it again. 4 has already been listed, so I don't need to list it again. So now I'll list the remaining elements, 6, 8, 10. So 1, 2, 3, 4, 5, 6, 8, 10. Each one of those numbers is either inside of A, or it's inside of B, or it happens to be inside of both. All right. A intersection B. The intersection of A and B, let's start off by asking ourselves, what does it mean? It's the things that are inside of A and also inside of B at the same time. So now I need to look at these two sets and ask myself, what elements do they have in common? And we already know there's a 2 that's in common to both, so 2 will be inside of A intersect B, and there's a 4 that's in common to both, so a 4 will be inside of A intersect B. Every other element is not inside of both sets, so that's it. There's only 2 things inside of A intersect B. Okay, let's do A union C next. A union C, we're looking at anybody who's inside of A or inside of C or inside of both of them. So I'll do kind of the same thing that I did before. I'll start off listing everybody who's inside of A because that will all definitely be included. And now I'll add in everybody who happens to be in C, just making sure not to duplicate. C has a 2, but I've already listed it. C has a 4, but I've already listed it. C has a 5, but I've already listed it. Okay, C has a 9, I'll need to list it. And C also has a 10, I'll need to list it as well. All right, and one last one to do. I have C intersected with D. So what C and D have in common? I'm looking at C, it has 2, 4, 5, 9, 10. None of those numbers happen to be inside of D. So unfortunately, C and D, the intersection between them is an empty set. So I would write that C intersect D is the empty set. Again, I just want to be careful about notation. If we said C intersect D is 0, that would not be true because 0 is a number. We're not talking about numbers, we're talking about sets that contain numbers. What would be true would be if I write C intersect D equals the empty set, 0 with the slash through it. That's telling me and telling the reader that we have a set that has no elements inside of it. In other words, there was nothing in common between the C and the D. All right, 2 more to do, and this is where we're going to need to start to think about breaking things down into steps. So first for E, if I'm looking for A union B intersected with C, I can see this A union B is in brackets. So I guess my first move is I'll need to figure out what A union B is. And we already did that on the previous page, but we could always do it from fresh here. A will have 1, 2, 3, 4, 5 in it. So all those things will be inside of A union B. B has 2, 4, 6, 8, 10. We've already listed the 2 and the 4. So 6, 8, 10, all that is there that needed to be listed. Good. So we've listed everybody inside of A union B. Now that we've done that little bit of rough work, we can ask ourselves, A union B and C together, how do they combine with that intersection? What does A union B and C, what do they have in common? So now I'll be taking a look at A union B and taking a look at C and asking myself, what kind of overlap do we have? C has a bunch of elements in it, 2, 4, 5, 9, and 10. So I have to ask myself, which, if any, of those items happen to be inside of A union B? A union B has a 2, and so does C. A union B has a 4, and so does C. A union B has a 5, and so does C. A union B has a 6, which C doesn't have. It has an 8, which C doesn't have. It has a 10, which C does have. So looks like I found 4 things. There are 4 things inside of C, the 2, the 4, the 5, and the 10, and those 4 things all happen to be inside of A union B. For the second part here for F, I'm going to need to do sort of 2 steps of side work. So first, I'm going to need to figure out what A intersect B is. And then once I've done that, I'll need to figure out what D intersect B is, so my second set of brackets, and I'll figure that out. Once I've done that, then I'm going to combine them. I'm going to combine the A intersect B and the D intersect B, and I'm going to combine them with a union, and then I'll have my final answer to this question. So let's start off with A intersect B. What A and B both have in common, there's a 2 that happens to be in both sets, there is a 4 that happens to be in both sets, and that's it. For D intersect B, D has a 6, 7, and an 8 in it, and the 6 and the 8, they happen to be inside of B also. So D intersect B has 2 things in it, a 6 and an 8. And so now we're going to ask ourselves, what happens when we take A intersect B union D intersect B? Make that look a little bit better and more like a D. There we go. And so I'm taking anybody who's in the first set or in the second set or in both. There's nobody that happens to be in both, so there's no overlap. So I'll just take everybody inside of A intersect B. I'll take everybody inside of D intersect B, and that should give us everybody who's inside of one set or the other or both. Okay, we've already sort of explored this in the last example. We had in the previous example D and C, we found that those two sets, their intersection was the empty set, that they didn't have any elements in common. We have a special name for when that happens. Actually, we have two special names, and they both mean the same thing, so you can use them interchangeably. If you have two sets where there's nothing in common, if there's nothing in one set that also happens to be in the other, you could call these two sets disjoint, or you could call those two sets mutually exclusive. They both mean exactly the same thing. So in the previous example, just scrolling back, I could say because C intersect D was the empty set, I could now say C and D are disjoint. I could also say C and D are mutually exclusive. All right. In addition to this, I want to throw in one last special set. We've talked about the empty set, which is the smallest possible set that we could be talking about. We also have the largest set that we could be talking about, the universe or the universal set. Depending on how it's typed out, sometimes it's written as a regular capital letter U, sometimes it's written as a sort of more fancy cursive letter U. Either is the same, it doesn't really make that much of a difference notation-wise. What it means, though, the universe, this is all the elements that we might be discussing. So, for example, I might have a set A that's students who are in Camosun Math 109, and I might have a set B, students that are in Camosun English 100, and I might have a set C, students that are in Camosun Physics 140. Where all of these sets are inside of might be the universe of all Camosun students. So all of my individual sets that I'm thinking about, there's a bigger set that they're inside of. Then that would be the universe or the universal set. I needed to define this universe because we do have one more operation, and this is the operation complement. Complement refers to the opposite of something. So when we're saying the complement of a set A, we're talking about everything that is not inside of set A. So in other words, that's everything inside the universe that's outside of A. We have three different notations, so depending on which books you read, you might see an A with a little tick mark, or an A with a little line on top, or an A with a little superscript of a C. The first two are the most common ones, and I'll probably be sticking with the tick mark, sometimes the little overline, whatever's most convenient. You can use whichever of the three you'd like. But again, the idea that the complement means the opposite of, everything that's not inside of. All right, some more examples. So here I have got a bunch of sets, and I just want to ask myself the question, who are mutually exclusive pairs? In other words, who have nothing in common? A and B, I'm looking at them and I can see A intersect B would have something in there, so they are not disjoint because A intersect B is not the empty set. A and C, on the other hand, A has A, B, C in it, C has a D and an E in it. This is disjoint or mutually exclusive, and that's because, again, A intersects C, that is the empty set. A and D have something in common, so A and D is not the empty set, so sorry, they are not mutually exclusive. B and C also have something in common. There's a D in common to both. So B intersects C is not the empty set. So too bad, they're not disjoint. B and D, B, D, F, A, E, there's nothing in common between B and D. B intersect D is the empty set. So yes, these are mutually exclusive sets. Last one, C and D, I can see that they have an E that's in common, so C intersect D, sorry, that's not the empty set, which means they are not disjoint, they are not mutually exclusive.